Professor Avi Loeb, welcome to Nervous Habits.
Thanks for having me.
So, Avi, to prepare for our conversation today, I did two things. I read your book, Extraterrestrial, first, and second, I rewatched the classic film 2001: A Space Odyssey. I think you were 6 years old when that movie came out, right?
Yeah, but frankly, I don't watch a lot of science fiction films and don't read much of the science fiction literature because I very often get upset when I see the storylines violating the laws of physics.
Wow. But you do know that 2001: A Space Odyssey, especially considering it was made in 1968, they say it was, extremely accurate given the time.
The point is that the travel between stars is a very long journey. It takes light 4 years to travel to the nearest star to us. And imagine a spaceship that travels at a speed much less than the speed of light. If we were to use the rockets that we are currently launching, like New Horizon or Voyager 1, Voyager 2, to get to the nearest star, we had to launch them back when humans left Africa in order for them to reach the nearest star right now.
Wow. That's incredible. So you actually didn't want to be an astrophysicist, an astronomer when you were younger. You wanted to be a philosopher.
And plan B was to be a farmer. I collected eggs every afternoon throughout my childhood.
Oh, wow. And when did you make the transition?
So in Israel, where I grew up, there is obligatory service in the military at age 18. And I had two options, either to run in the fields with a machine gun or to do intellectual work. And the second option appealed to me because I was interested in philosophy and physics sounded closer than running in the fields. And so I was recruited to an elite program that recruits 20 to 30 youngsters to do work in physics and mathematics that is beneficial to the security of the country. And I was fortunate enough to get my PhD at age 24, but also propose a project to the Star Wars initiative at the time by Ronald Reagan. And it was selected as the first international project to be funded. General Abramson liked the idea. He came to visit us, and that brought me to Washington. And in one of the visits, I decided to visit also Princeton, New Jersey, the Institute for Advanced Study, where Einstein used to be faculty member decades before. And they offered me a 5-year fellowship. They took a gamble on me, one of the professors there, John Bacall. And without that, I wouldn't be where I am. And everything was hard work throughout, getting adjusted to the nomenclature of astrophysics. I didn't know how the sun shines when I started.
And even, I mean, the transition from being a farmer, I think it's particularly remarkable. You wrote about in your book, which we'll chat more about in a few moments, how you would look up at the night sky and sort of wonder, where the light from the stars was coming from. For folks listening, just to clarify, I know this is very rudimentary astronomy, but when you're looking at a star in the night sky, Avi, you're staring into the past, right?
That's right. But also when you look at the mirror, you're looking at yourself when you were a nanosecond earlier, because there is a time, it takes time for the light to bounce off the mirror and get back to you. Now, if you place the mirror very far, it will take more time. And so if we look at the source of light very far away, it just takes time for the light to reach us. And what we are seeing is an image that was produced a long time ago. So if we are looking all the way back to the edge of the universe, we are seeing how it began. And it's good in a way because it's sort of like a time machine. You can see what happened in the universe at early cosmic times. That record is still available to telescopes. And that's how we learn what happened after the Big Bang, for example.
Absolutely. Yeah, I think listeners should buckle up because some of the numbers that you provide in the book are staggering. For those who have yet to read the book and who aren't familiar with the specifics, Avi actually notes that the Milky Way hosts tens of billions of Earth-sized planets with surface temperatures similar to our own. And you state at one point that when you add all the galaxies in the observable volume of the universe, it increases the number of planets to a zeta, a figure greater than the number of grains of sand on the beach of Earth. I mean, these figures are astounding, Avi.
It is, but I think the biggest message that the sky is sending us is be modest, because we live on this grain of sand on the landscape of a huge beach. And how can we be arrogant even if we accomplish a lot on this grain of sand? It's just such a small piece in the big picture. But moreover, we also live for a short time. And, we should be grateful for that, but humble and modest, and not assign too much significance for our superiority relative to another person. One of the things that is always puzzling me is how much of our effort and time and energy is dedicated to feel superior relative to another person. And that makes no sense given the big picture of the universe. And any competition we have among ourselves is really meaningless. It's like ants fighting on a single grain of sand, and who cares? The other sign of modesty is that we are not at the center of the action. Obviously, Aristotle, early on in human history, the ancient Greek philosopher, perhaps was justified in assuming that we are at the center of the universe. So he had this mental picture of the spheres around the earth, and it turned out to be wrong. And Copernicus and Galileo realized that the earth is moving around the sun. It's not that the earth is at the center of anything. And I think we are making the same mistake with respect to life. We think that, since we haven't found yet other extraterrestrial life, that we might be alone. And, that's similar to the mistake that my daughters had made when they were infants. When they were at home, they tended to think that, they are very smart and, very special, and the world centers on them. And when they went to a kindergarten, they found a lot of other kids and got a better perspective. And one way for us to maintain our modesty, which is very much appropriate, is to find others.
Mm-hmm. Yeah, definitely. It's almost like object permanence for infants or for dogs. You take something away and they think that it's gone, and then you put it back. That's sort of naivete. But Avi, I want to ask you, for folks that aren't familiar with the search for extraterrestrial life, what are the prerequisites for life on another planet? What exactly are astronomers looking for when they look for civilizations?
Right. So our imagination is often limited by what we already know. So what we know is life on Earth. And life on Earth is associated with chemical reactions in liquid water. So you would conclude from that you need liquid water to get life as we know it. Now, this is not a trivial statement, because if you take water ice and just put it in vacuum in space and warm it up, it will go straight into gas. It will not become liquid. The only way to get liquid water is if you have an external pressure of an atmosphere. And that's why the existence of an atmosphere around Earth allows for life. So Mars had an atmosphere early on, but lost it. And after Mars lost its atmosphere, everything dried up on the surface. We don't see oceans of water, liquid water on Mars. And perhaps that's the reason that Mars lost its habitability and there is no life there. But we want to find out whether it had life. The Perseverance mission that will land next month on the surface of Mars will look for signs of life that may have existed when Mars had an atmosphere. So just to summarize, you need liquid water. Liquid water can exist only if there is an atmosphere around the planet. And that means the planet needs to be roughly the size of the Earth, because smaller planets lose their atmosphere. Mars is 10 times smaller in mass. It lost its atmosphere. The moon doesn't have an atmosphere. You need a rock big enough such that the force of gravity can bind or keep the atmosphere bound to that object. And that's why when astronomers search for life, they often talk about Earth-sized planets around sun-like stars at the right distance, so that the temperature on the surface would allow liquid water to exist. And that is the current frame of searches that astronomers are doing for potentially habitable planets and maybe even signs of primitive life. They are thinking about building instruments that will, in the future, detect oxygen in the atmosphere. The problem I have with that approach is even if we detect oxygen, it will not tell us conclusively whether life exists, because the Earth for the first 2 billion years didn't have much oxygen in the atmosphere. So there was microbial life, there were microbes on the surface of the Earth, but not much oxygen in the atmosphere for half of the Earth's lifetime. And that means that if you don't find oxygen, it doesn't mean that life is not there. And moreover, oxygen can be produced by other chemical processes, by breaking water and so. So it will never be conclusive. And one way to get conclusive results is if you find industrial pollution, because those molecules, the CFC molecules that are produced by refrigerating systems and industries here on Earth, they cannot be produced by nature. And if you find evidence for that with the same telescopes, that would be conclusive.
Wow. So it's so fascinating hearing you talk about this stuff. It's one of those situations where I almost wish I was listening, to this as an observer, because it's so there's so much to unpack there. For folks who have been following the news, Avi, a couple of months ago, there was phosphine discovered on Venus. Now, I noticed that you said that liquid water was a prerequisite, assuming that the atmosphere was conducive to that. Would phosphine be one of those other compounds that might be indicative of life, even if there was no water?
Well, that's a good question. And actually, the idea behind the phosphine was that it's produced by microbes in the cloud deck of Venus. So the surface of Venus is too hot. It went through a greenhouse effect, and so the surface cannot host life on it. But if you go up to an elevation where the temperature is just like the temperature at the lower atmosphere of Earth, at the cloud decks of Venus, you can find that the temperature and pressure of the atmosphere to be very similar to the conditions on Earth. And the idea behind this claim was that maybe there are microbes in droplets, droplets of water or some other liquid, and they produce the phosphine. Now, we don't know. Well, there are still, since the announcement was made on the 14th of September, 2020, the observers reduced the significance of their detection. It's now 5 standard deviations, and it's not completely beyond the reasonable doubt that they actually detected phosphine. So we have to wait for more data on that. But even if phosphine is definitely found there, the question is whether only a biological origin, only microbes can produce it. Because we know that, for example, volcanic activity can produce it, but there is just not enough volcanic activity on Venus to do it. And on Earth, phosphine is produced by microbes. So it's very intriguing, but not yet conclusive, a work in progress. Most of science, I mean, the public needs to understand that most of the time in science, we don't have enough evidence to make conclusive statements, and it's work in progress most of the time. And it's also a learning experience. Scientists can make mistakes, and they make mistakes very often. Yeah. And so the image that many scientists try to portray, whereby they only announce things after they are 100% sure about them and they are always right, that image is not correct, because you see in the phosphine case, they try to maintain that image. So they sealed all information until the press release, the press announcement. And then they sat on a stage and announced the discovery. Okay. Mm-hmm. Now, that sounds respectable. And that is what the mainstream of the scientific community wants. Only announce results when you are 100% sure. Okay. So they did that. But after their colleagues went back to the data and criticized the way they did the analysis, they had to revise the conclusions. So the point is, it's an integral part of science, doing it by iterations and trying to pretend, with a facade that it's just like a teacher in a class where you tell the students what the truths are, what the knowledge is. This is not the way science works. And even if you are sure, and they were sure, they had this press conference, they had to revise the conclusions. And it's not clear whether those conclusions are correct at this point. So the point is that why not from the get-go be straightforward with the public, tell the public there is always some uncertainty, and it's done by iterations, and sometimes scientists are wrong, and if the public sees that, then I think there will be more trust in the scientists. It wouldn't look like an occupation of the elite. It wouldn't look like the scientists are putting themselves on a pedestal where they lecture the public about, it would be more of a shared experience where, there is some evidence, we're trying to figure out the truth together.
Oh, wow. Okay, so I know we're gonna get to Oumuamua in a few minutes, but I really want to stay on this topic because it calls to mind. There was a quote from the book, Avi, which reinforces everything you're saying. Where at one point you said, "There's so much we do not know that I often wonder whether another civilization, one that had the benefit of pursuing science for a billion years, would even consider us intelligent." And that really hits home your point about modesty. Modesty, when you conceptualize if intelligence is sort of like a linear spectrum, and to the left is the single-celled organisms, to the right is mammals, and then primates and humans. Who's to say that humans aren't, there aren't, to the right of humans, species exponentially more intelligent than we are? That would be that arrogance that you're speaking of.
Right. And I don't think that we are the smartest kid on the block because our technologies were developed only over 100 years, and there could be kids on the block that developed their technologies for much longer, a million years, a billion years. And there might be, and also this soup of chemicals that we talked about that created life as we know it, it's just like baking a cake. And if you look at recipe books, you can start from the same ingredients and bake cakes of different qualities. And I don't think that we are the most tasty cake that one can imagine. Just look at the news cycle, and we are wasting a lot of resources on fighting each other. We're not very intelligent. One reason I look at the sky for intelligence is because I don't find it very often on Earth.
That's very funny, but also poignant as well. Avi, I want to ask you something you've probably never been asked before. Maybe I would imagine, but I'm sure listeners are wondering if there is intelligent life anywhere else in the universe, whether it's in the Milky Way or elsewhere. What might these beings look like? Should people listening be expecting green tentacled slime monsters like we see in cartoons? Would they be more or less like humans? Would they be corporeal at all? What is your best guess?
We will be shocked. They will look nothing like we expect. And I actually have an essay in Scientific American that I posted yesterday on this subject.
Wow.
And take, for example, the nearest star. Okay, that it's this Proxima Centauri, which is a dwarf star. The most common type of star. Actually, the sun is not the typical star in the Milky Way. It's smaller stars that are much more abundant. And our nearest neighbor is Proxima Centauri. It's 12% of the mass of the sun, and roughly half the surface temperature of the sun. So it's cooler than the sun, and it emits mostly infrared radiation. So the sun emits visible light. That's why we have eyes that are sensitive to what's most available to us, which is visible light. And near Proxima Centauri, there is a habitable planet. It's called Proxima B.
Mm-hmm.
And if there are any animals on it, they will have to have infrared eyes. Wow. And that would look very different. And by the way, since these types of stars are the most common, there is no surprise. It's not surprising that interstellar travel agencies do not assign Earth as a good, as an attractive tourist destination, because our grass is green. The grass on most habitable planets is dark red. And so imagine you are an animal with infrared eyes. Would you go on vacation to Earth? No way. It will be just too bright and in the wrong part of the spectrum. You would go elsewhere. So maybe that's why they don't visit us. We should entice, if there are creatures out there, we should entice them to come for a visit and share with them a water-based drink, Wow. But the point is that I think it would look something like we have never seen before, very unusual, and even more so if we deal with technology, because technology that is 1,000 years old would be unrecognizable to us.
So I can see why you don't like science fiction movies, because you probably watch E.T. and think to yourself, the extraterrestrials don't look anything like that. That's
Yeah,
preposterous.
it looks too cute, too similar to humans. Yeah.
That's great. So I want to get into Oumuamua, because that's pretty much the focus of your book. It obviously was an interstellar object discovered in 2017. Oumuamua means scout or messenger from a distant object. So sort of, Avi, set the scene for listeners. What was so significant about this object at the time that it was discovered 3-4 years ago?
Right. It was the first object from outside the solar system that we've spotted near us. And at first, astronomers thought it's probably a comet, because these are the most abundant objects we have in the solar system. And if this object was lost from another star, it's probably a comet. And the only problem is it didn't show any cometary tail. There was no trail of gas coming from it as a result of evaporation of its surface by sunlight. So people said, okay, maybe it's just a rock that doesn't have any ice on it, and therefore it doesn't evaporate. And the only problem with that was that it exhibited an extra push away from the sun that you often find in comets as a result of the evaporation. And there was no evaporation, so the question arose as to what creates this extra push. And then another anomaly about this object was that as it was tumbling, like a piece of paper tumbling in the wind, it was changing its brightness, the amount of sunlight that it reflects, by a factor of 10, which is a lot. And that means that it has an extreme geometry. And in fact, the best model for explaining the light curve was that of a flat object, pancake-shaped, not cigar-shaped. And so the question is, given all the anomalies, and there were several others that I detailed in the book, what is this object and what gives it the extra push? And we suggested in a paper, scientific paper, that it may be just the reflection of sunlight from its surface that gives it the extra push. And that would imply that it's very thin, because otherwise the reflection of sunlight will not accelerate it enough. And then if it's very thin, nature doesn't make such things. It resembles a sail on a boat that is being pushed by the wind. Here, the sail is pushed by light, and that is called the light sail. And our civilization is developing this technology for space exploration. The one advantage is you don't need the spacecraft to carry any fuel, because it's being pushed by light.
Okay, so if we have any doctors listening, it sounds like you almost sort of went through a differential diagnosis. You said, okay, so it could be a rock, or it could be a comet. It doesn't have the cometary tail. It could be a light sail. It could be a reflection of light. But ultimately, in the essay you wrote in 2018 for Scientific American, you said, you know what? I think that this is a relic of an alien civilization. So why was that the ultimate conclusion you came to with regard to?
Because it looked nothing like anything, nothing like an object we have seen before. And in fact, after I wrote this, the Scientific American essay and also the scientific paper, in the subsequent years, mainstream astronomers tried to explain Oumuamua's qualities, unusual qualities, its anomalies, based on a natural origin. And all the scenarios that they contemplated involved nothing that we have seen, something that we have never seen before. Okay, like for example, a hydrogen iceberg or a pile of dust, and these objects that they invoked to explain Oumuamua seemed less plausible to me than an artificial object. And that's why, I just followed the clues. I think that we should put a technological origin on the table and not dismiss it. Currently, in the scientific community, there is a taboo on discussing this possibility, even just mentioning it. And I think it's inappropriate, given that the Earth-Sun system is common. And given this sense of modesty, why should we assume that something like that does not exist out there? And when you walk on the beach, you often find seashells and rocks that are naturally produced. Every now and then you stumble across a plastic bottle that is an indication that the civilization is out there. So we can do the same thing by searching our backyard within the solar system for objects that come from far away.
So you say that the scientific community wasn't particularly receptive. I'll tell you, back in 2017, 2018, I didn't hear a lot about Oumuamua. I didn't see it in the news. I wasn't reading about it in the papers. It wasn't trending on social media. There seems to be a general lack of awareness about this. Do you think in part that's because of the reluctance of the scientific community to be open-minded to this?
Definitely. The scientific community prefers business as usual. And, I went to a seminar at Harvard with a colleague of mine and about Oumuamua. And at the end, when we left the room, he said, "This object is so weird, I wish it never existed." And to me, that's appalling, because a scientist should always be should be happy about receiving a lesson from nature. If nature gives you an anomaly, you should be happy because it teaches you something new. You cannot be upset because it moves you out of your comfort zone and you want everything in the sky to be rocks. You cannot be upset about that. Reality doesn't go away even if you ignore it. So the point is, by putting blinders on the interpretations that we're allowing, we actually just maintain our ignorance. We don't do anything else. And as a scientist, we should entertain all possibilities that seem plausible. And I think the problem with the astronomy community right now is that the search for technological signatures is regarded peripheral. There is not much funding to it. Young people are bullied if they are interested in it. Mm-hmm. And so this is similar to stepping on the grass and saying, look, it doesn't grow. And it needs to change. And of course, the public is extremely interested in this. The public funds science. And I think it's irresponsible for the scientists to say, we have the instruments to examine these questions. We just don't want to discuss it. Beyond that, I think it's the most conservative approach is to say that we are not special or unique, that since the circumstances are being reproduced in many other places, the outcomes are also reproduced. And we just need to look for it. The public is being starved on this subject by the scientists not wanting to discuss it. There is a taboo. And as a result, nobody is talking about it. And when you see an object like that, you don't hear much about it. But I hope that my book will change that perception and will drive the scientific community to a better dialogue with the public. We should all work together.
I think that's part of the reason why your book has and will continue to generate so much buzz, because there is such a dearth of this, not just in literature and in the scientific community, but in the media and in the public. I do think you're right. There is an appetite for this kind of research. And it does seem like some of the smartest minds are being lured to other areas in astrophysics or astronomy, as opposed to learning about extraterrestrial life. And Avi, I wonder if some of that is because of the psychology of it as well, as opposed to just the business side of the scientific community. But I wonder, and you talk about this in the book, if there's a general ambivalence for the search for life because we don't like to think about it on a psychological level. What do you think about that?
I think that's an interesting possibility because, with my daughters, obviously, they thought that the center of the universe, that they have special qualities until they went to kindergarten. And one way for them not to become modest and to continue to be arrogant would have been to stay at home, right? And it's a way of maintaining your illusions about yourself. And psychologically, it helps your ego not to see something else that might be better than you or that may threaten your preconceptions. And there is a fear from that is very deeply rooted, and perhaps that explains it. Obviously, it will have implications to religion as well and to other aspects of our life. But the way I see it is that knowledge is always beneficial. We always want to know what reality is, because ignoring it is not to our benefit. Science gives us better knowledge of what reality is. And if you look at medicine, there were, in the Dark Ages, there were arguments against operations, against dissecting the human body, because it has some magical powers, because it has a soul. And if modern science would attend to these arguments and would say, let's shy away from studying bodies of humans because there is all this nonsense being said about them, where would we be in terms of our medicine today? Science should ignore things that do not make sense, that are being said in the science fiction literature, that are being said about unidentified flying objects. It's completely irrelevant. If we can address the same subjects with scientific tools, with our instrumentation, with our telescopes, and answer the fundamental questions, we have an obligation to do it, given that the public is interested.
It's really a shame that you're not as much a fan of the scientific movies, because this is just such a great opportunity to mention the Matrix and the red pill, blue pill, because it just seems like it's that sort of ignorance that they're choosing to take the blue pill and live in their simulated realities rather than understand the red pill. You're one of potentially billions of races of intelligent lives.
Well, I should say, there is the situation in science right now in physics is even worse than we were discussing. It's not just that you find mainstream physicists shying away from a discussion about the search for technological signatures or alien civilizations. It's that you find people pursuing, theoretical physicists pursuing ideas that have no foundation in evidence, nothing to back them up from experiments such as extra dimensions, the multiverse, string theory. And this is considered part of the mainstream and respectable. And people do intellectual gymnastics with sophisticated mathematics, but that has nothing to connect to experimental data. No umbilical cord to any evidence that we are collecting. And they still claim that they carry the torch of physics forward. And I ask you, how is it possible to have a culture like that entertains ideas that mainly serve the purpose of showing that the person who works on them is smart? Okay, so that's the main. So people do all kinds of sophisticated math that demonstrates that they are smart. But is that really the purpose of doing physics? I was brought up thinking that we're supposed to find what nature is. It's not about us, it's about nature. And to have this distortion that the mainstream regards speculative ideas that are not testable by experiments as completely valid, and people have been working on them for decades. And then another portion of the mainstream says, no, we don't want to discuss the possibility of technological civilizations because that's part of science fiction, because of this, because of that, because it's never aliens. To have these two things combined, to me, is a complete distortion of the culture of the way science should be done, which is driven by evidence, driven by curiosity, driven by the public's interest. If the public is funding science, we should attend to the public.
Definitely. I can hear in your responses the inner philosopher in you, Avi, about how you really just want to answer the big questions, not turn away when the evidence doesn't perfectly, match up with what your expectations were. In the book, you mentioned that if we ever do encounter intelligent life, humans will be ill-equipped to deal with it. So, imagine that there is a discovery a couple of years from now, somewhere on Earth. Maybe I know you probably saw the monoliths that were discovered and what that might mean. What do you think the reaction would be, and why exactly are we ill-equipped to deal with it?
Yeah, there is no protocol, for example, for a contact with another civilization. The United Nations that didn't come up with a set of rules, and nobody's thinking about it. But it's an unlikely event. I think we are not of enough interest to merit a visitation to the planet. I think most likely we will find something flying by, or we'll find a signal, I think it will have a major impact if the evidence is conclusive. For example, a photograph of an object like Oumuamua that doesn't look like a rock. The response would be dramatic because it would change our perception of our place in the universe. It would imply that maybe we're not the smartest kid on the block, especially if it's advanced technology. Maybe we can learn something from it. There would be new areas of studies such as astrolinguistics, how to communicate with other civilizations, astropolitics, astroeconomics. You can think of any combination of astro with things that we have right now, which are limited to Earth right now. So I think it would just be the most important discovery in the history of humanity.
Okay, so it would change the education system for sure, because there'd be more of an emphasis on astronomy and the specific niche areas in science. It would probably change government, you would imagine, and I mean religions. I can't imagine the impact that it would have on monotheism and polytheistic religions.
Right. I mean, in the case of governments, I would hope that we can unite as the human species rather than have separate nations with borders and disputes and so forth. That's my hope that it will bring. Mm-hmm. With respect to religion, it's not clear. I mean, I spoke with religious people, and many of them claim that it wouldn't affect too much. But if you look back at history, Giordano Bruno claimed many centuries ago that during the Dark Ages that other stars might be just like the sun, and that they may have a planet like the Earth around them. He didn't know it for sure, but he just made this conjecture. And he said, okay, in that case, there might be life on those planets. And he was burnt at the stake for saying that. It was considered heresy at the time. And it just shows you how it can be offensive to some people to recognize that there is life elsewhere. And in the case of Giordano Bruno, it was because the church at the time, not the church now, but back then, they were, they said, well, if there is life elsewhere and it's sinned, then you need to have duplicates of Christ to save that life. So you need multiple copies of Christ visiting each and every planet on which life had sinned. And that was unacceptable. And so they burned the guy.
And it comports with what you said earlier about how close-minded the community is with regards to Copernicus and how, people were convinced that initially the sun, the Earth didn't revolve around the sun. The Earth was the center of the solar system. Now, Avi, I know that you also, you wear a lot of hats at Harvard and in your studies, and you also were involved with the Black Hole Initiative, the world's first center of the interdisciplinary study of black holes. What piqued that interest? Because that's sort of tangentially related to what we're saying, but also a little bit different.
Right. So back in 2015, 16, we decided to establish a center that focuses on the study of black holes because they are very enigmatic objects, very exciting objects, structures of pure space and time that serve as an ultimate prison. Even light cannot escape from a black hole. And it's a fascinating subject. And we brought together astronomers, physicists, mathematicians, and philosophers under one roof. And I am the founding director of that center. At first I worried that it would be just like the Tower of Babel, where people will speak different languages and never be able to cooperate. And it turned out that after a few months, collaboration started, and now it's a very active and interesting intellectual environment that I really love and enjoy. In part because I started with interest in philosophy and I ended up as an astronomer, but now I have an opportunity to speak to philosophers and we collaborate. And I had several papers with philosophers. And so it's an interdisciplinary environment that is quite unusual. And over the past 3 years, the Nobel Prize was awarded twice for the study of black holes in physics, the Nobel Prize in physics. And that's remarkable. So I just gave a talk yesterday, a colloquium in Stockholm, congratulating the Nobel Committee for their good taste. But the title of my talk was Black Holes Are in Vogue. And this is something that should not be taken lightly because in 1939, Albert Einstein wrote a paper that he published in Annals of Mathematics where he argued that black holes don't exist. So we went a long way, and I'm sure that Einstein would have loved the new evidence that black holes exist that came from gravitational waves produced when two black holes collide at the edge of the universe, and that was one of the Nobel Prizes.
Yeah, I mean, I think you're right. It is very much in vogue, and it's also a terribly complex issue. I feel like we could spend 1,000 podcasts just fleshing out, the black hole discussion, as in and of itself. For those listening, Avi, who might, I know this is a little bit absurd, but they might be concerned with being drawn into a black hole. What's the likelihood that the Earth will be drawn into Sagittarius A, that's the closest supermassive black hole, or that the sun itself will descend into a black hole, Avi?
Oh, very small. The sun, let me start with the sun, because we know what will happen to it. In about 7 billion years from now, which is roughly twice or a little less than twice the current age of the sun, it will consume its nuclear fuel. So the sun is, or a star in general, is just a nuclear reactor. You have hot material inside that burns up through nuclear reactions, just like in a nuclear reactor on Earth, except it's a fusion reactor. So you get light elements like hydrogen coming together, bumping against each other and creating energy by fusing. And this nuclear reactor, in difference from the ones we have on Earth, where they are situated in concrete, a star is held by gravity, by the force of gravity. So it's a nuclear reactor that is stable and keeps itself together by the force of gravity. And then once it finishes its fuel, there is no more stuff to burn. It starts cooling off. Well, at first it expands, and then the core of the sun will start cooling off and eventually become a remnant, a metallic remnant, a piece of metal the size of the Earth, which is called the white dwarf. And that will carry about 2/3 of the mass of the sun, will sit in an object that is the size of the Earth. And that's what the sun will be more than 7 billion years from now, like 8 billion years from now. And then, so no worries about the sun becoming a black hole. And the worry is
the sun's not going to be a black hole.
That before it does it, it will actually expand, and then it will boil off all the oceans on Earth. And that will happen within 1 billion years. We have to find another home, because currently all our eggs are in one basket. We have to spread them, because in 1 billion years, we will definitely need to leave Earth. All this talk about global warming, mitigating our impact on the environment, that will become completely irrelevant when the sun will boil off all the oceans. We must be out of here. Okay. So we should think about where to go, and there are destinations. For example, the planet around Proxima Centauri has a permanent day side, a permanent night side, and there is a permanent sunset strip in between. And my daughters really want to have a house there in the permanent sunset. But speaking about the black hole at the center of the Milky Way, it's 6 billion times more massive than the sun. But it's extremely far away. It's 24,000 light years away. So its gravitational pull on the Earth, on the sun, is negligible. It will never soak us closer. The only impact that it can have, and that's actually a paper that I'm working on right now, is if there are flares, if there is matter falling into that black hole, and that creates flares, X-rays and ultraviolet radiation, that could impact life on Earth, but at a very minute, not at the dramatic level, but at a modest level, that could have an impact.
Okay, and just since we're talking about black holes, for those listening, a very elementary question, but can you talk about spaghettification? If you did get drawn into a black hole, what exactly would happen to an object?
Right, so let's talk about the black hole at the center of the Milky Way, that is 6 million times the mass of the sun. If the sun were to approach it, then when it gets to about 10 times the size of the black hole, the region from where you cannot escape, if it gets to 10 times that, which is roughly the Earth-Sun separation, at that distance, the sun will be spaghettified, become a stream of gas. and will be basically destroyed. This is called tidal disruption of a star. And we see such events actually in other galaxies. Every 100,000 years or 10,000 years, a star comes too close to the black hole and gets spaghettified, and we see a flare from the infall of the gas and the heating up of the gas. It shines brightly, and we see the flare. If, on the other hand, you imagine an astronaut falling towards the black hole, then nothing will happen to the astronaut because our body is not held together by gravity. The sun is held together by gravity, so it can easily get ripped apart. But our body is held by chemical bonds that are much stronger than gravity. So as a result, we can pass through the so-called horizon of the black hole intact. An astronaut can go through and not much will happen to the astronaut, unlike the sun case.
Wow.
But then once you get into the event horizon, into the region where you cannot get out of, within half an hour, we will fall to the singularity, the so-called, the pathological place where Einstein's theory of gravity breaks down because the curvature of space and time diverges. And there, our body would be ripped apart. So close to, and so we will be short-lived, less than an hour once we enter. The astronaut would not survive. By the way, I gave a talk about black holes when my daughter was in the kindergarten, and one of the boys was fascinated by the story of what happens to an astronaut, and he kept asking me, and what will happen to his body? And then the caretaker, the person in charge, said, Dr. Loeb, would you mind speaking about something else, please? It will cause nightmares to the kids.
Well, if anything, it relieves the nightmare knowing that it's a billion years before any of us have to worry about this. So,
oh, yeah.
I'm sure a lot of listeners are put at ease by that. And I know that also there was another physicist that dedicated their life to the study of black holes. You worked with Dr. Stephen Hawking for a little bit as well. What was that experience like?
Well, I didn't actually do research with him, but I hosted him in my home when he came to visit for the inauguration of the Black Hole Initiative, actually, and also the inauguration of the Starshot project to launch a light sail to the nearest star. And he was an amazing person because he was disabled, couldn't do much with his body, but he had a very positive spirit. He was forward-looking and enjoyed life. That was amazing to me because other people would be depressed by their physical condition, but he really enjoyed life. In one of the evening events, when it ended, he said to his caretakers, he said, "I'm bored. Let's go to the bar and have some drinks." He also had affairs throughout his life with his nurse, and so he sort of lived the life to the fullest, despite the limitations. And I went to his funeral at Cambridge University to pay respect. And at the end of the funeral, which was a religious ceremony, they played this Frank Sinatra's song, "Fly Me to the Moon." And in a way, it represents his joyfulness about life and also about doing science. He was extremely original and capable scientist, one of the best that we had in the 20th century.
That's amazing. You really don't hear about that side of him, so it's awesome to hear that perspective. So just to round out our discussion, I have a couple more questions for you here. Occasionally we get young listeners on the podcast who sort of like the young boy who is interested in black holes, is looking at beginning their career in the sciences and might have an interest in the search for extraterrestrial life. Given all of the struggles and challenges that we've spoken about, what sort of advice would you have for young listeners?
I think the future will be better than the past, and that's why I'm doing what I'm doing. And when I was young, I served in the military, and there is a saying among the soldiers that sometimes a soldier has to put his body on the barbed wire so that others can pass through. And so my hope is that by preparing the ground in the way that my book does, I will make this subject acceptable, and the future generations of young scientists that are excited about the search for extraterrestrial life will be able to pursue it without hesitation. And I actually have a textbook coming out in 6 months that is about the science of the search for life. Uh, Extraterrestrial is more of a popular level book, but the way I see it as an integral part of mainstream in science, and I hope that within my lifetime it will become such.
Yeah, I think it's very likely because of what we've discussed, about the buzz and how things are going to continue to develop in the field moving forward. And to bring our conversation full circle, in the book you mentioned that the reason why you were interested in astronomy was to answer the big questions in philosophy and religion, like what is the origin of life and are we alone in the universe? I'm curious, and I know you've been asked this before, but how have your answers to these questions sort of shifted after your decades studying astronomy, or have they?
Oh, they did, definitely, because the more knowledge I acquired, the sharper the questions became. And currently, we don't know what happened before the Big Bang, for example. So I'll give you an anecdote. I'll unify the issue of life and the beginning of the universe. And so imagine that we developed a theory that unifies quantum mechanics and gravity so that we can understand how to make a universe in the laboratory by irritating the vacuum. Suppose we find a way of making a synthetic universe, a baby universe. Well, that would explain the Big Bang, because the Big Bang may be our umbilical cord that leads us to the laboratory where our universe came from. And then our universe gave birth to us. And we will create a baby universe in our laboratory in which additional civilizations will create another baby universe. So just like human beings having babies and the human species continues, it might well be that there are baby universes all the way.
Baby, it's like that meme. Do you know the one where it's like it's all cake? It's the astronaut. I don't know if you're familiar with that. Are you are you familiar with simulation theory? Because it's sort of what you're talking about.
Oh no, I dislike this theory. I think it's equivalent to being high on drugs. I mean, if you think about the reality not being real, of course you can think that way if you have enough money in your bank account, right? So you have people taking care of you. But if you have to work for your money, and if you have to pay attention to reality, you cannot think that it's a simulation, because you if you try to cash something you don't have, you will be put under very difficult circumstances. And so I think it's important to be close to the evidence and believe that reality exists. Because I haven't seen yet any crash the way you see in computer simulations, like a pixel not looking sharp or something falling apart. Until I see it, I would believe that reality is real, and that's the way I would behave. And obviously, people that are on drugs, they don't really get the information from reality. And believing, having an academic position at Oxford and arguing that we live in a simulation, it may be possible because you have tenure, you can say that, and you can still keep your salary every month. But that's not an approach that I would advocate for an active human being that is trying to make a living.
Unless you can make a living off of your research that we're living in a simulation. It's sort of circular. Well, listen, Avi, this has been an absolute pleasure. I've enjoyed speaking with you almost as much as I enjoyed reading your book. I'm sure listeners want to know where they can go to buy Extraterrestrial and how to learn about your work in general.
Yeah, so the book is available on Amazon and any other bookstore. And it's coming out on the 26th of January, so just a few days from now. And I encourage anyone that enjoyed the discussion here to have a look at it. You can find more information about me on my website. So just put my name, Avi Loeb, on Google, and you'll get to my Harvard website that features all my commentaries in Scientific American, some videos, and my scientific papers.
I'm definitely going to look up that article that you mentioned from Scientific American about it was about the prerequisite for life. Was that about the phosphine you mentioned earlier?
Well, that also. So I have every week or two, I have a new commentary in Scientific American. And if you go a few back, then you get to the phosphine one. If you go to the last one, it relates to something else we discussed. So just scroll down the titles and you will find the one you're interested in.
Got you. Well, I mentioned this to you earlier, but your book was incredible. I couldn't put it down. It's one of those books where I just found myself saying, "Oh, I'll read a couple pages," but then got through it in a couple hours. And you've left me and the listeners with a lot to think about just the big questions and how little, like you said, a grain of sand on the beach is humanity. So I really appreciate you joining me and taking the time.
Thank you so much for having. I enjoyed a lot our conversation.